when gravity wins. What happens when gravity wins? When it overpowers everything, even light itself? Today, we're exploring black holes, nature's ultimate gravity traps, the most extreme objects the universe has ever produced. Hello and welcome to Astrobitica, your home for space news and information. Here we take the vast mysteries of the universe and turn them into a story that you can actually understand, remember, and share. So before we begin, make sure to subscribe and tap that notification bell so that you'll never miss another journey through the cosmos. How black holes are born. Every black hole begins as a star. Not just any star, though. Only the most massive ones can meet this fate. When such a star burns through its nuclear fuel, fusion, the process that keeps it shining, comes to an end. Without that outward pressure from fusion, gravity takes over completely. The star's core collapses inward. Atoms are crushed. Even subatomic particles are squeezed beyond comprehension. The collapse is so extreme that all the star's remaining mass is compressed into a point of infinite density, known as a singularity. Around this singularity lies the event horizon, an invisible boundary marking the point of no return. Cross it, and escape becomes impossible. Not even light, the fastest thing in the universe, can get out. To an outside observer, it looks as though anything falling in slows down and fades from view, frozen in a time at the edge of the event horizon. Inside, the laws of physics as we know them cease to operate in any unfamiliar way. The different kinds of black holes. Not all black holes are the same. Stellar mass black holes form from collapsing stars, usually a few to several dozen times the mass of our sun. At the other extreme are supermassive black holes, containing millions or even billions of solar masses. Nearly every large galaxy, including our Milky Way, has one at its core. The Milky Way's central black hole is called Sagittarius A star, about 4 million times the mass of the Sun. Between these extremes may lie the so-called intermediate mass black holes, objects hundreds or thousands of times the Sun's mass. They're harder to detect, and astronomers are still searching for definitive examples. They may represent a missing link in the growth of supermassive black holes. What black holes are and aren't. Contrary to the way science fiction often depicts them, black holes don't wander the galaxy, sucking in everything like cosmic vacuum cleaners. If our sun were suddenly replaced by a black hole of equal mass, Earth's orbit would remain almost exactly the same. We would continue circling at this same distance, now only in total darkness and cold because the sun's light and heat would be gone. A black hole's pull becomes deadly only near its event horizon. Get too close, and the difference in gravity between your head and your feet, something called tidal forces, would stretch you apart atom by atom in a process grimly nicknamed spaghettification. But at safe distances, black holes obey the same laws of gravity as everything else. They're not cosmic monsters so much as cosmic consequences, the final act of massive stars. Seeing the unseeable. For most of history, black holes were purely theoretical. Then, in April 2019, the impossible happened. Astronomers working with the Event Horizon Telescope released the first ever image of a black hole's shadow in the galaxy M87, about 55 million light years away. It wasn't a photograph of the singularity itself. That's impossible. What we saw was a glowing ring of superheated gas swirling just outside the event horizon, orbiting at nearly the speed of light. The dark center was the shadow, the region where light falls in and never returns. That moment turned black holes from abstract equations into visible reality. Humanity had, for the first time, seen evidence of the most extreme prediction of Einstein's theory of general relativity had ever made. Do black holes last forever? In the 1970s, physicist Stephen Hawking asked a daring question. What happens at the edge of a black hole when we add quantum mechanics to Einstein's equations? His calculations led to a surprising answer. Black holes aren't perfectly black. Tiny quantum fluctuations at the event horizon allow them to emit a faint glow of energy, now called Hawking radiation. That radiation means black holes can very slowly lose mass over unimaginable timescales, far longer than the current age of the universe. Eventually, though, they could evaporate entirely, releasing their remaining energy in a final burst. In other words, even the darkest objects in our universe might not be eternal. Despite their destructive reputation, black holes also play a creative role. At the centers of galaxies, supermassive black holes act as engines of cosmic evolution. As matter falls toward them, it heats up and emits enormous amounts of energy, powering quasars, some of the brightest objects in the universe. These outbursts can shape their galaxies by driving away gas and regulating how new stars form. In this sense, black holes don't just destroy, they sculpt. They help decide the size, structure, and even the lifespan of galaxies. Some scientists now think that large-scale webs of galaxies stretching across the cosmos, the very skeleton of the universe, owes part of its form to the influence of these immense gravitational anchors. Even now, black holes remain one of the biggest frontiers in physics. They sit at the crossroads of general relativity and quantum mechanics, the two great frameworks that describe our universe but don't quite yet fit together. At the singularity, those laws collide. Gravity becomes infinite, time and space lose meaning, and our equations break down. Understanding what truly happens inside a black hole may be the key to a deeper, unified theory of physics. So the next time you see that now famous image of a black hole, remember what it represents. It's not just a cosmic abyss or a symbol of destruction. It's a window into the most extreme environment nature can produce, a place where our understanding of reality itself begins to unravel. Black holes remind us that even in a universe governed by order and mathematics, there are still places that defy complete explanation. They are the boundaries of knowledge, the edge of what it means to know anything at all. If you learned something new today, give this video a thumbs up, subscribe to Astrobitica, and tap the bell so you'll never miss another journey through the cosmos. Until then, keep looking up and stay curious.